How do we feed a growing world without wrecking the planet? It's one of the biggest questions out there. And a huge piece of that puzzle is right there in the soil, specifically the fertilizer we use. Farmers absolutely need nitrogen for good crops, but here's the thing, a ton of it just disappears. It never even reaches the plant. Today, we're going to dive into some really cool research that's tackling this exact problem head-on in cotton farming.
Think about it. When a farmer buys fertilizer, that's a serious investment. So what happens when a huge chunk of that investment literally washes down the drain? Well, it's a double whammy. It hits the farmer's wallet, for sure, and that lost fertilizer, which turns into nitrates, can cause some major environmental headaches. The real question is, how do we stop the waste?
Okay, to really get this, we need to talk about one key term, nitrogen use efficiency, or NUE. The easiest way to think about it is like you're trying to water a plant with a leaky bucket. If that bucket has a bunch of holes, most of the water spills out before it ever gets to the roots, right? A low NUE means you've got a really leaky bucket. You're pouring in tons of fertilizer, but the crop is only getting a little bit of it. The goal, obviously, is to patch those holes and get that NUE number way, way up.
So, to figure out the solution, first we have to understand the problem. Let's take a look at the old playbook, especially for farming in dry places like the American Southwest. We're going to see why traditional cotton farming has such a leaky bucket when it comes to nitrogen. Here's the issue in a nutshell. The most common way to water cotton in this part of the world is called surface irrigation. And really, that's just a fancy way of saying you flood the field. So when you apply nitrogen fertilizer with this huge rush of water, a lot of it just gets pushed deep into the soil, way below where the plant's roots can ever hope to reach it.
And this slide just lays it out perfectly. Look on the left. That's your traditional surface irrigation. All that water causes what scientists call deep percolation. It literally shoves the dissolved fertilizer, or nitrate, deep, deep down. That nitrate leaching is the #1 way nitrogen gets wasted. Now just look at the overhead sprinkler on the right. It's a completely different story. It's targeted, it's controlled, and the water goes right where it needs to, with hardly any waste.
And wow, the numbers on this chart really tell the whole story. The difference in how much fertilizer the plant actually gets is massive. With surface irrigation, the crop only recovers somewhere between 21 and 61% of the nitrogen you put down. That's a huge potential for waste. But switch to an overhead sprinkler system, that number skyrockets to between 81 and 97%. That is a much, much less leaky bucket.
Okay, so we know the old way has a serious flaw. But what if, instead of just guessing how much fertilizer a plant needs, what if we could just ask it? That's the amazing idea behind this new high-tech solution. It's all about letting the plants themselves tell us exactly what they need when they need it. So meet the hero of our story. This is the Proximal Sensing Cart Mark 1, and it was developed by the USDA. Now, it might look like a simple piece of equipment, but this cart was designed to roll through cotton fields and gather incredibly precise data about the health of every plant. It basically gives them a voice.
So how does it listen? Well, it's decked out with a whole suite of sensors. There's an ultrasonic sensor that measures how tall the plant canopy is, an infrared thermometer checks its temperature, which can be a big sign of stress, and a spectrometer measures what's called canopy reflectance. That's basically the specific shades of color the leaves are reflecting, which tells us a ton about their nitrogen levels and overall health.
So to put it simply, the cart is doing 3 things at once. It's checking how big the plants are, it's seeing if they're maybe running a fever, and it's looking at their precise color. By pulling all that data together, researchers get this real-time, high-def picture of exactly what the crop needs at any given moment. Okay, so you've got the old, wasteful method, and you've got this cool new high-tech cart. What's the next step? Well, you put them in the ring together for a real-world showdown, and that's exactly what they did in a field test in Maricopa, Arizona.
Here's the setup for the big showdown. On one side, you've got the old way. They apply fertilizer based on a single soil test done before the season even starts. It's basically an educated guess. On the other side, you have the new way, using the cart's real-time data to apply fertilizer only when and where the plants show they need it. It's a totally dynamic, responsive approach.
And the results? They were absolutely staggering. The new method, the one that listened to the plants, used 50% less nitrogen fertilizer than the old way. Let that sink in. Half. For a farmer, that could mean thousands of dollars in savings, not to mention a massive reduction in their environmental footprint.
But hold on. This is the question that every farmer is going to ask. I mean, it's awesome to save money on fertilizer, but not if it means you get half the crop, right? So did cutting the nitrogen by 50% end up hurting the final cotton yield?
And here it is. This is the knockout punch. Just look at this chart. There was zero reduction in yield. Let me say that again. The new method used half the fertilizer and produced the exact same amount of cotton. It got the same result with unbelievably better efficiency.
So, how did that work so well? This finding from the research paper gets right to the heart of it. The old soil test method was simply over-prescribing fertilizer. It was treating the soil like a blank slate. What it didn't account for was the nitrogen that's naturally released from organic matter in the soil, a process called mineralization. The new method, because it's measuring what the plant is actually using, it automatically accounts for that natural nitrogen source. And that leads to a much smarter, much more accurate application.
So this wasn't just a small victory, it was a total game changer. Let's just break down what this means for the future of agriculture.
When you boil it all down, the takeaways are just crystal clear. This tech saves farmers a whole lot of money. It drastically cuts down on nitrogen leaching into our groundwater, which is great for the environment. It does all of this while getting the same great yields farmers count on. And maybe most importantly, it proves that data-driven precision farming isn't just some sci-fi idea. It's the real, practical, and efficient future of how we grow our food.
And all of this leaves us with one last, really fascinating thought. This technology let us ask cotton plants how much nitrogen they needed, and they told us. But that's just the beginning. If we can build tools to listen this closely, what other secrets about water or pests or disease are our crops just waiting to tell us? The field is wide open.